Okay, ladies and gentlemen, welcome to my talk about optimizing batch and streaming aggregations. I didn't know what to pick for the title, so I apologize if it's not clear, up front what I'm going to talk about. Aggregations for me are aggregate queries, structured aggregate queries. We are going to talk about Spark SQL and Spark Success Streaming. No relation to any concrete version of Apache Spark, just a general overview of what you can expect from the latest and greatest, which is 3.4.1, something that I focused on lately. Okay, so my name is Jacek Laskowski, and this is Apache Spark. No Databricks at all, except that the venue is, theirs, not ours. So great shout out to them. Okay, for inviting me, for having me here, and for you to come and listen. Thank you so much. So let me take a picture. So now you are going to be, and by the way, just today, I got a message from Twitter telling me early in the morning that I started spamming on Twitter. Can you imagine this? How weird it is. How can you spam on my own Twitter, right? Twitter account. If you don't bother, you should just stop listening and that's it, okay? No spamming at all. But just got banned for the very first time. I've got 3 days to obey the rules. No idea what they are, but okay. And I'm hoping that batch and streaming aggregations are gonna be much, much easier to understand because the rules are clear, okay? Or clearer, or can be clear, more important. Okay, ladies and gentlemen. So, a little bit about myself. I'm Jacek Laskowski, independent consultant, IT freelancer, call it whatever you want. Whenever you need me, just ping me, and the very first question I'm gonna ask is this something about Apache Spark and Databricks? If the answer is no, the next question is going to be about Apache Kafka. Is this something about Apache Kafka? If the answer is no again, we're done, okay? That's my life, okay, for now. And that's been for the past 10 years, okay? I was quite happy to have enough clients, so the stream of money was enough to keep me afloat, okay? So now I'm here to talk about what I managed to learn while looking at the source code of Apache Spark. So every day, after some running session or stretching, I just have a look at the source code of Apache Spark, Delta Lake, possibly Kafka, and I'm taking notes. And after a couple of notes, there are some clients, they ask questions, so I improve these notes, and eventually there's this idea to talk about it at Data AI Summit. And believe me, I'm so scared, and I've got no words to talk about. I know the topic very well, but I'm so stressed. So apologies if you notice it and you feel uncomfortable as well. Okay, I'm best known by internals of online books. There are quite a few where you can just read my English, because English is important, but math is importanter. And you can contact me at jacek@japila.pl. If you've got any questions about Spark and Delta Lake, I may respond to these emails immediately. If not, ping me again. If I get annoyed, you will have to pay for our interactions. So worry not, it's not gonna be as like this. And follow me on Twitter, still on Twitter, thinking about Fostodon. Okay, table of content. This is our talk. So 5 minutes intro. So we've got another intro to internals of structured queries. We've got internals of aggregate queries, which are subset of structured queries. If you've got no idea what I'm talking about, this is exactly the talk you should be listening in or tuned in. Scala UDAFs and aggregators. Very deep or very, very deep depth of Spark SQL and structured streaming. So speaking of streaming, we'll be talking about streaming aggregates, then about my performance gig that made me believe that I can talk about this topic today. okay? And then recap things to watch out for while you are invited for similar performance gigs in the future. So, intro to the internal self-structured queries. Just let's set the stage, okay? Apache Spark, what it is. It's just general purpose compute engine. That's it, distributed compute engine, okay? Think of it like a yarn, think of it like a resource manager of any kind. Spark can only execute queries, computations described, expressed using RDD API. In other words, whatever you can find in Apache Spark, whether it's Spark SQL, Spark Success Streaming, has to be or have to be transformed into RDD-based API code or RDD API-based code, okay? So, whether you are thinking in data frames or data sets or SQL, eventually you will face problems with RDD API because eventually this code is transformed internally at runtime by Spark to be executed as a set of stages and tasks. That's that easy, okay? I'm not gonna go into too many details, but just setting the stage. Spark SQL is just a module that uses this concept of distributed computation described using RDD API, this lazy language API, to describe queries using good old SQL or Python or pandas-like data frames, okay? In other words, Spark SQL made Spark closer to the masses, okay? To people, to folks who are not into distributed computation yet, but they are fine with pandas, but we all know what problems pandas, Python can bring to our table, and eventually we need some distributed environment. And this could be Spark and Spark SQL or Spark Success Streaming, okay? Including Spark MLlib. Spark Success Streaming is just an extension, another extension, but this time of Spark SQL to write streaming queries. In other words, think about Spark SQL batch queries executed regularly at a given interval, okay? Just like a cron or add command on Windows, Unix operating systems. Okay, I might be exaggerating, but this is just to setting the stage, okay? So we are on the same page. Okay, queries, whether they are for Spark SQL or Spark Success Streaming, can be described using higher level APIs or operators. Okay, so you might be familiar with DataFrame or dataset, whether you are Python dev or Scala dev or Java dev. And you could just use SQL, good old SQL, okay? So as you can see, just by this slide, you can appreciate the beauty of Apache Spark, bringing all the people together on the same platform, okay? So if you still are not certain to use Spark for your distributed computation of any kind, think again, because you might be losing, you might be experiencing FOMO. In most cases, optimizing streaming queries, speaking about Spark Success Streaming, is to optimize corresponding batch queries. So something I'm going to talk in a moment, this performance gig, started with me trying to abstract away from all the streaming problems or issues, because streaming, as you will learn in a moment, is bringing its own issues, problems, okay? Making our mental model tougher to grasp or build, develop, okay? So I wanted to abstract away from streaming problems and make it batch, and it helped me a lot, which you will hear in a moment. But just know that not all streaming problems can be, transformed into corresponding batch queries. Well, you might be missing something that really impacts what you are facing on production, okay, in production. So start your performance gigs trying to abstract away from streaming But remember, this caveat is that streaming issues may really be the root cause of your problems. OK, this is about structured queries. Any questions? No questions. Good. So higher level query language. It could be DataFrame API. OK? It could be Python. It could be Scala. It could be Java. OK? If you feel you are adventurous enough and you know how to code, do so. But beware of all the problems that you are causing while showing off with your coding skills, which we are going to talk in a moment. So another variant of high-level query language supported by Spark is SQL, good old SQL. Okay? So the same query that you could write using Python, Scala, Java, or could be expressed using good old SQL. So why not to use SQL? Well, and this is a very valid question, because as you will see in a moment, you are giving even more, much more opportunities for Spark to optimize your queries. So rather than showing off with your programming skills, which I know I myself suffer from it too, we all want to disregard for our projects. Just think how to express your queries using good old SQL, because just by rewriting your code onto corresponding SQL queries-based code may give you performance boost, just by doing this. Okay? Might not be obvious, how to do it in many cases, but it's worth giving it a shot. Okay, so query execution looks like this. Okay, so under the covers of any structured query execution is this component called query execution. Okay, this query execution starts with you writing query using SQL or dataset API, and in most cases, shall I say in every case, whether you are using SQL or dataset API leads to the same performance characteristic. Okay, so start with SQL, fine. Start with dataset, fine. But whether you are using SQL or dataset will lead to create something that Spark can understand better, something that's now more visible, explicit in Spark Connect, which is unresolved logical plan. Something that knows what you, developer, whether you used SQL or Python, Java, Scala, doesn't really matter, wanted to express. Okay? How Spark sees your world is through this unresolved logical plan. Why is this logical plan unresolved? Because you might be using tables that are not available in your catalog, first of all. You might be using types or functions that accept types that are not compatible with your table's schemas. So that's why there is this analyzer that analyzes your query, make your unresolved logical plan resolved, analyzed, and then once you pass analyzer, you can bet on having at least one result. Whether it's OK or not, it's up to your query, but from Spark SQL perspective, you will get something. Okay? So your query is valid and executable. That's what analyzer is for. And there are other stages, or shall I say phases, not to confuse you with stages in RDD API. You've got other phases up to optimized logical plan that got translated into physical plan that's going to be executable, and eventually you will end up with RDD API-based code. And whether you are using Java, Scala, or Python or SQL, you will end up with RDD-based code, often written internally or rewritten using Java. Can you believe it? So regardless of your language of choice, you will end up with, in most cases, in Java-based code. And that's what Spark will execute eventually, leading to all the performance benefits you can expect from Apache Spark. So you've got logical and physical operators. Logical operators are just basic ingredients of your logical query plans. They get optimized until Spark Planner will rewrite your query into corresponding physical operator tree. Okay, so tree of physical operators. And you can find among logical operators, there are operators like aggregate, join, local relation, logical RDD, and so on and so on. You can expect at least one logical operator for any high-level operator you use in your query. So whether you are using SQL, select, you can expect logical operator called project. For projection, because select is for projection. If you are doing grouping, you've got this logical operator called aggregate, and so on and so on. Sorting, order by, they are all rewritten into corresponding logical operators that are rewritten, planned by Spark Optimizer into Spark Planner, sorry, into physical operators like adaptive Spark Plan exec or broadcast hash join exec, blah, 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 exec, and other blah, 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 exec. So all physical operators are execs. But what you can see in Web UI will be the names without this exec suffix. OK? So that's what you can map now in your mind, what you may have seen in Web UI to what I just showed or said. And so in terms of aggregate queries, I pretty much said all this already. So aggregate queries, just some theory, just to set the stage and feel you more comfortable with my nomenclature terminology. So aggregate queries for me are queries that calculate single value for a group of rows. Okay, group of rows can be 0 rows, 1 row, or thousands of rows. Okay, and aggregate queries, something that I learned while exploring or while preparing for the talk, to be honest, is that aggregate queries can be broken down into 2 parts. Did you know about it? I didn't. So there is this part called grouping that's described by GroupBy clause in SQL or GroupBy operator in DataFrame API, possibly guarded by having SQL clause, as well as the other part of this aggregate queries, which is aggregation itself described using aggregate functions. They could be user-defined aggregate functions. They could be written in Scala, Python, using pandas, for example, or it could be built in standard aggregate functions. Okay, so there are lots of possibilities, but just know that there is this grouping and aggregation parts. Structured queries end up with aggregate logical operator. So whenever you use GroupBy operator, know that you will have logical query plan with aggregate logical operator. That's where this journey starts. Okay, our talk starts. So you've got GroupBy, high-level operator, including grouping sets, which has no Scala Python alternative. So you have to use SQL to use grouping sets. There are also with cube and with rollup. There is pivot also, but all in all, all the aggregations lead to aggregate logical operator. You can also use higher level operators like GroupBy or GroupBy key, depending on your needs. Okay, GroupBy key is more for programmers to please them, so you can still use this fancy platform called Apache Spark, but you should be fine with SQL as well. As a matter of fact, the more you code your Spark application, the less performant code you create. So it's contrary to your belief that you can just write your queries perfectly fine and get the best out of Apache Spark. No, in most cases, it's the opposite. That's very surprising to many of my clients, especially developers, who hate, sorry to say it, hate Apache Spark for letting them code less. Okay? Spend time less on doing their coding stuff. They can code almost no lines because that's the purpose of Apache Spark. abstract away from all the optimizations, and once you start coding, you are doing too much. Okay? That should be a red flag. So you've got basic aggregations, you've got multi-dimensional aggregations, and something that I'm not going to cover during this talk has other support, which are window aggregations. Okay? So just know that out of all these aggregations possible, using this group by SQL operator or a dataset group by key, there are different types of aggregations like basic, multi-dimensional, and window aggregations. Any questions? Awesome. They say I can explain tough stuff easily. Thank you to prove it. So let's start with this aggregate query example. Okay, it's a very simple query. Okay, you can get full steam ahead and write something more sophisticated. That's one of the many reasons why I say to my customers who invite me for performance geeks to not show me their code at all, unless I ask about it, if at all. In other words, just let me rephrase it. Your code is something that won't likely help me. Because we are all devs, we've got all our own coding preferences, design patterns we follow, all the religious, ways of, expressing our beliefs and thoughts in our code. I don't want to see it. I don't want to hear it. So when you call me and say, hey, Jacek, can you help me with my problems? The very first question is, what's your problem? Why do you think it is a problem in the first place? Because it's slow. How can you know? This is my next question. I'm very aggressive. Sorry for this. So now you know when you call me. So next question is, how do you know? How could you even expect this query is going to be faster? How much you know about all the algorithm stuffs, all the math, that's need to describe your ideas? Perhaps algorithm is wrong. Yeah, possible, right? So I'm asking these questions just to get to the point. Then they say, hey, this is this exception. Okay, so it's not about performance, it's this exception. I say, exception. Okay, that may tell me something. Okay, now I'm talking to the right person, aka Apache Spark, because it is him to talk to me. Okay, so I'm looking at this exception, and then I can guess that was the query. So I reproduce, or how to say it, what's the name to recode, reverse engineer. Yeah, I can reverse engineer your code. And since I'm Scala dev mostly, you might be Python dev, we may eventually get to the point that we can understand each other, even though we are speaking different languages. Okay? So that's the point, me avoiding looking at the code. So this is one query, and there is another query, okay? Well, there is no another query. So this query ends up as this logical query plan. And as you can see, this query led to this parse logical plan. So as you can see, the very last operator is this infamous aggregate logical operator. So now you know why I don't want to see your code. Because when I see this, I know enough what you wrote. I don't want to see all the classes, all the design patterns, virtual methods, abstractions over abstractions. Well, no. I would spend weeks and lead to no results, which, as you may have guessed already, my clients are not willing to pay for, right? So that's why I'm just asking these very basic questions, often annoy my clients, so they share what they really mean by saying their queries don't work. So I see aggregate. So this is logical plan. Now, I see, explain output, and I see that this logical plan was transformed into corresponding physical plan, aka #HashAggregateExec. So this #HashAggregateExec was chosen as the way to execute your query. Now the question is, why? This is the very first question I'm asking myself, when I see this, and by the way, if you see hash aggregate, you can just say, OK, I'm giving up because this is the fastest possible aggregate operator. So out of 3 possible aggregators, which are hash aggregate exec, object hash aggregate exec, and the last but not least, sort aggregate exec, hash aggregate is the fastest possible. So should I even bother? So before sending my invoice to my customer, I say, there is nothing to be improved on, or you are going to pay for a week or 2 weeks me hunting down something that might not be even huntable, if I may put it this way, OK? So are you going to spend week or 2 weeks of me hunting down something that's not even in their code, or something that's not possible in Spark? In most cases, my clients say, OK, 1 week is enough. And I say, good. 1 week is awesome, because then I can improve my nodes, because I dig deeper into the source code and can improve my nodes, which is beneficial not only for my customers, but also for you. So we've got these possible aggregations. I'm looking at these different shapes of these aggregations, and I know about this aggregation execution planning strategy. There are quite a few planning strategies. Among them is this aggregation that selects the proper aggregation physical operator for your queries. There are some requirements that all the aggregations have to meet, but eventually you will end up with this physical plan, and it's only because of this aggregation execution planning strategy. So you've got hash aggregate exec physical operator, and this is for hash-based aggregation. If you see hash aggregate exec, you should be fine, in most cases. There is nothing you can do to optimize it from aggregate physical operator's perspective, OK? Because you've got the fastest possible. Why is it the fastest? Because there is no sorting, and there is a hash map involved under the covers. And this hash map uses the very basic ingredient of Spark SQL computation, part of Tungsten execution engine, which is unsafe row. Unsafe row is unsafe row is based on this unsafe Java, classes, sunmisk unsafe. If you've ever heard about it, fear not, Spark uses it. That's why some people claim Spark is a compiler for your queries. So unsafe row keys and values uses something that's called Tungsten aggregation iterator. So all the operators will have their own aggregation iterator. And this aggregation iterator uses unsafe fix blah, blah, blah map. OK? And just know that it uses it as long as it has enough memory per task on your machines. And if it runs out of memory, it starts spilling to disk and starts becoming sort-based aggregation. So there is this moment where if I see it, when I see that, when I say I see it through this performance metric called number of sort fallback tasks. If you see it in your queries, this metric number of sort fallback tasks, it means that your best hash-based aggregation turned itself into something very slow, which uses sorting. And why is that? You run out of memory. So how to improve it? Well, increase memory available to your executors. That's the simplest possible solution. Is it acceptable? No idea. Okay? Depends on your budget. And what you should be aware of is that hash aggregate exec supports whole-stage Java code generation, which generate Java code under the covers to make your queries faster. So it's not that all aggregate operators support whole-stage code gen, but this one does support it, and it's OK. That's why it's the fastest. There is another one, ObjectHashAggregateExec, physical operator, and this physical operator is worse compared to the previous one. Is used for object aggregation. What do I mean by object aggregation? I mean that you can group by your own custom object rather than something that's described by unsafe row. So you start using your own custom objects, and as you can see, as a developer, you are paying the price of you showing off. You are doing too much. You are confusing Spark, and you are leading to worse performance because you wanted to spend more money on your work, write more code. You should have used SQL in the first place. That's my answer. OK, and there is this special configuration property called Spark SQL Object Hash Aggregate Sort Based Fallback blah blah blah. That configuration property controls how many keys and values pairs this object aggregator will use before it falls back to sort-based aggregation. In other words, it's 128 pairs. So once you start seeing that you are falling to sort-based aggregation, it means that you cross this threshold of 128 key value pairs. So you are grouping over two, how is it called? Too many keys, sparse key space, if I may put it this way. So you've got too many keys. So this object hash aggregation eventually leads to the worst possible operator, which is sort aggregate exec. But before switching to this next operator, just let me point you that object hash aggregate exec does not support whole stage code gen. So it's important to avoid object hash aggregate, which leads us to this conclusion that you should avoid programming too much and do it very little, if at all. Okay, because you will end up with object hash aggregate exec first. Second, you will trade your time over whole stage Java code gen, which will lead to slower performance, lower performance. And the last but not least, sort aggregate exec. As you may have guessed, this is for sort-based aggregation, uses its own aggregation iterator, and this is the least performant out of these three possible aggregate operators. Okay, and this one supports whole stage Java code gen, but only for no key grouping, which means you are grouping over the whole data set. So there are some limitations. OK, so the very important metric is number of sort fallback tasks. That was something that I learned during my last performance Geek. It showed itself in few iterations, and I was curious what it is for. And it turned out that this metric shows you when your faster operators, aggregate operators, or switching into the least performant aggregate operator. So when you see number of sort fallback task metric being non-zero, it means that you are losing your performance. You need to do something. What it is, increase this threshold for object hash aggregation, or do some other stuff with hash aggregation, possibly increase your available memory. Okay? Any questions? Yeah.
If I cannot increase memory, so I have a hard limit, or I already use largest box, can I just increase parameter?
OK, let me repeat your question so we are on the same page and others will hear it. So if I understood this question properly, correct me if I'm wrong, the question was about what can I do if I have this hard limit on how much memory I can assign to my queries? Was this your question? Well, you've got your hard limit, so you cannot do anything but accept reality that you've got this hard limit, correct? That'd be my first answer. I know, you expect something else, but I'm not a magician. I'm just Spark expert, and I can only offer you help, as far as Spark can, give you.
But did you try to shuffle?
Yes, we'll get to it, yes. There was this mentioning, shuffles, 200 perhaps partitions. AQE is also another problem. So yeah, there are so many moving parts that, once we start having this conversation, I know that I'm speaking to someone who understands, the very bottom of Apache Spark, so I can give you more, okay? But the very first reaction to your question, to your question would be, well, you've got your hard limit, so we can't do much about it. Okay? Yeah, I can understand. So Scala UDFs and aggregators. We've got the last 5 minutes, so I need to be extra careful not to invite you to ask questions. So Scala UDAFs and aggregators. Once you start using Scala UDAFs or Python UDAFs, which are supported at least in 3.4.1, the latest and greatest, you will suffer from this less performant ObjectHashAggregateExec or sortAggregateExec. You can stop thinking about hashAggregateExec. So once you start using user-defined custom aggregate functions, you immediately pay this extra performance price. Okay, that's basically like this. Moreover, UDFs, including UDAFs, so user-defined functions, including user-defined aggregate functions, are not optimizable, cannot be optimized by Scala Optimizer, Catalyst Optimizer. So, well, they should be avoided for some other reasons, not only that you are using them for aggregations, and aggregation, have lower performance. So, streaming aggregates, they are very similar to our batch aggregations we talked about. They use the very same high-level operators, yet with streaming data sources, like AKA connectors. These days, we call them connectors. So we've got dataset group by as well as group by, a SQL operator. So that's nothing new. So whether you're using batch or streaming, nothing really changed. But you've got this extra streaming-related issues, okay? Problems, something that may hit what you are hunting down in this performance geek. So output modes, complete, append, update, and some others. Well, there are no others. Late data, watermarking, event time, limitations related to aggregations over streaming data sets, blah, blah, blah. There are quite a few things to think about. Do you need them? Probably not. So if you can escape this trap of seeing too many problems, just rewrite your code into corresponding, just to see if you can nail the root cause of the problem into a batch query, and then try to find the root cause. Okay. There's enough to think about or scare you while optimizing streaming queries. Okay? Among streaming connectors is Kafka connector. So let's talk about Kafka connector. So Kafka connector is to support loading and storing records from to Apache Kafka. That's basically it. But the key to understand this Kafka connector is that this Kafka connector adapts to the number, the number of topic partitions. So if you've ever worked with Apache Kafka, you know that you've got topics, and topics are partitioned, just like RDDs in Apache Spark. So Spark tries to adapt to topic partitions. So the more you've got topic partitions, the more you've got RDD partitions. And the opposite is also true. Okay? So one way to optimize your queries over Kafka using Kafka connector is to repartition your topics. That's one of the many ways available. So this performance geek, 1 minute left. I had a client. And now you know that this client were full of Scala devs, crazy devs who wanted to show off how they can code. Yeah. And they faced me, okay? So the very first time I met them, I said, no Scala whatsoever. They said, what? No, it can't be. Okay, I knew it's not gonna be easy. I said, what do you have? Well, we have streaming aggregates. So you know that they already lost HashAggregateExec already, immediately. Okay, I knew it immediately. Then they use UDAFs over their own custom Java objects, Scala objects, case classes. Said, yeah, memory issues now. And they also use Kafka connector. So I said, oh, how many partitions? Can you change them? No, we cannot. Oh, man, okay. Just this hard memory limit. We cannot change topic partitions, so we are doomed. Okay, so you can translate all their saying, all their words into ObjectHashAggregateExec. Number of partitions is the number of topic partitions. You can also think about this Spark SQL ObjectHashAggregate sort-based fallback, which is 128 keys. And then, and the last but not least, you should look for number of sort fallback tasks metric, and I did see some of the tasks showing me this metric to be non-zero, meaning we run out of available space to hold all our keys. So my recommendation, rewrite UDAFs to good old SQL or columns using catalyst expressions. That was not easy to implement. Some queries were rewritten. Repartition, that leads us to this question about number of partition. Why do we need repartitioning? Well, because this Spark SQL object hash aggregate sort-based fallback metric is per task. So the more tasks, the more partitions we have, the smaller our data set we aggregate upon. Meaning, we can accommodate enough keys within this 128 space, right? So that was one idea. I'm not saying this is something that you should implement right away, but you should just think about it. And the last but not least, shorten trigger processing time. Why is that? It's because it shortens how often you execute your queries, leading to less data to process in your streaming batch. Meaning, you can use your object aggregation without falling back to sort-based aggregation, which is exactly what we want. We improve our performance. So that was approved. I got paid. I was happy. I'm here. So things to watch out for. Recap. So we've got, why did I use it? So there are three possible aggregate physical operators: hash aggregate exec, object hash aggregate exec, and the last but not least, the slowest out of these three, sort aggregate exec. Use column expressions as long as possible. No Scala, Python, Java code, please. Okay? Whole state Java code gen is something that you should think of. It's supported by hash aggregation as well as sort base. No support for whole state code gen for object aggregation. Okay? Don't use UDAFs because you are paying the extra price for using a hash aggregate exec. So unless you've got no choice, yeah, that's my answer to this question. Use mutable data types, no strings, please, because they are unbounded, meaning that Spark can get worse performance if you start using keys based on strings. So basic primitives like booleans, bytes, dates, numbers are OK. So do translation onto corresponding objects so you can get a better performance. Promote hash aggregate exec by using mutable data types. And the last but not least, observe a number of sort fallback tasks metrics. Aim for zero for this metric, telling you that everything is OK with aggregation. And this is the last one, but not least, should I say. Consider repartitioning. Oh, no, there is another one. OK. So configuration properties are also important, if not important. And that's all, folks. Since we ran out of time, I'm not sure you've allowed to ask any questions. But if there is a wish to ask a question, go ahead. That's all from me. So